In this video, we're going to look at outliers. Now, so far we've noted that there might be some extreme values in our data set. In this video, we'll look at two formal ways of identifying whether or not a data set has any outliers. I've avoided using the term outliers so far because in A-level maths, there are technical definitions of what constitutes an outlier. Let's take a look at a box plot of the February sugar intake. Now, you don't need to follow along with this. I'm just going to plot it to demonstrate. Now, as we can see, in this box plot, the outliers have been calculated by Plotly and indicated with these little circles here. These are values that don't really fit with the rest of our data. Often they're shown with crosses instead of dots, and there are two approaches to identifying which values are outliers. One of them using the interquartile range and one of them using the standard deviation. Let's have a look at our February sugar values and start with the interquartile range. First of all, the IQR approach says that if a value is more than 1.5 interquartile ranges above the upper quartile, above Q3, then it is considered an outlier. Now, looking at our box plot, we can picture this. If we imagine the interquartile range here, that's this distance of the length of the box. If we times that by 1.5, so make it 50% longer, it might be about this long. Then if we add that distance on top of here, we get taken up to here. And anything beyond that is considered an outlier. So these points here are outliers, and so we just move our whiskers down to kind of the first value or the last value that isn't an outlier. Similarly, at the other end, anything less than the lower quartile take away 1.5 IQRs is an outlier. Now, there aren't any at the lower end of our sugar data. Now, we can actually calculate these in Excel. Let's have a look at what the outlier boundaries are for the February sugar. So if you do this as well, open up a new tab called Outliers. And we're going to need the upper quartile, sometimes called Q3. We're going to need the lower quartile, sometimes called Q1. So Q2 would be the median. And we're then going to need the interquartile range. And we're going to use that to calculate the upper outlier boundary and the lower quartile boundary. The lower outlier boundary. So to calculate the upper quartile, we want to do equals quartile, open brackets, select our data, so Feb sugar, comma, and then we want the upper quartile here, so we're going to choose 3, close the brackets, and there we go. And we can just copy and paste that down and change the 3 to a 1 for the lower quartile, enter, and to work out the interquartile range, do 1, take away the other, and there we go. So for the upper quartile boundary, we're going to say that is the upper quartile plus 1.5 lots of multiplied by the interquartile range. And for the lower quartile boundary, that is the lower quartile take away 1.5 lots of the interquartile range. And there are our boundaries. Anything above 2563 grams is an outlier. Anything below minus 1055 grams is an outlier. Obviously, no one consumes negative sugar in our data, so there aren't going to be outliers at the lower end. That's why our box plot didn't show any. If we quickly have a look at our box plot, 2563 grams. That ties in with what we've got there. Anything above 2563 has been flagged as an outlier here. Now, we don't necessarily know what calculations Plotly is doing to calculate outliers, but we're going to talk about the ones that you need for A-level maths. And we can actually flag which of these values are outliers in our data set, and we're going to create a new column. So right click, insert, and we're going to call this outliers. And this is just going to come up with a 1 or a 0 if that particular value is an outlier. So we're going to say equals if, open brackets, that number there in M2 is greater than 2563, comma, then yes, it is an outlier, or 1, comma, otherwise 0, no, it's not an outlier. Close the brackets, hit enter. And we can apply that all the way down. And if we highlight the column, because we've used ones for yeses, it will quickly add it up and tell us that there are 17 ones here. There are 17 values here which are outliers, and that again matches up roughly with what Plotly has calculated as well. The other approach for checking for outliers follows a similar logic. If a value is more than 3 standard deviations above or below the mean, then it's considered an outlier. And we can do those calculations quite quickly as well. If we go back to our outliers tab, we need the mean, we need the standard deviation, and then we're going to work out the upper and lower outlier boundaries. So equals mean, no, not mean, average, open brackets, of our Feb sugar, close the brackets, enter, and also equals stdev, standard deviation, open brackets, same again, February sugar, close the brackets, enter, and so if we've got our mean, we want the equals mean plus 3 lots of the standard deviation, and equals mean take away 3 lots of the standard deviation. So anything above that number is an outlier, anything below that number is an outlier. And they are similar values to what we got here when we did it with the interquartile range. One of the reasons for the difference between these boundaries is that our data is a little bit lopsided. It's a bit skewed. Basically, the box plot is not symmetrical. Now, when we have such skewed data, the interquartile range approach is bound to identify more outliers, as the calculation of the interquartile range doesn't take these highest values into consideration, whereas the standard deviation method does. The standard deviation does account for these a little bit, and so it allows a slightly wider window of kind of accepted values, and it will have fewer outliers. For the purposes of what we're doing here, either the IQR approach or the standard deviation approach will suffice. Now that we've identified some outliers in our data, we should inspect them quickly and decide what to do with them. Sometimes outliers can be caused by error, such as error in measurement by the participants, or simply a typo when we're working with the data at some stage. But other outliers will just be particularly big or small values that we might want to exclude from our analysis. Let's just have a look and filter at the outliers here. So here's our 17. Now remember, these are people whose sugar in February was an outlier. Now, if we look at how much sugar they consumed in January, all of these people did consume quite a lot of sugar in January, and so actually none of these February intake values are particularly suspicious. So I'm going to say these are probably accurate. They're not down to error. And because these people are important to us, we want to know how effective sugar-free Feb is at the upper end of the sugar intake spectrum as well. I'm going to keep them in. We're not going to exclude these people from any analysis, so that's fine. Also note that lots of them are young and they are male. Now, if we opted to remove them, we'd be messing with the picture quite a lot. If we were removing more males than we were females, or more young people, that's not going to be fair on our data. The last thing to mention in this video is that exam boards vary with the definitions of what makes an outlier. So some here say 2 standard deviations, instead of 3. And sometimes you'll be given a different definition to use in the exam, but the principle is still the same. Have a go at these exercises, check your answers, and then move on to the next video.